In the beginning, there was nothing. And then, bang, AEL was born. Astro's Electronics Lab brings you entertaining, sometimes silly videos relating to electronics for your enjoyment. Follow along with his frustrations and antics and maybe learn something in the process.
Hypnotic, isn't it? I've received a package. It's like Christmas. I'll get this open and we'll have a look at what we've got. Nice baggie. Right. This is going to be my power switch for this amplifier project. Now, I got this from Queensland. It's about 12 bucks. And it comes with a O-ring, because these are supposed to be waterproof switches. And the reason I got this is because, well, it's nice and large. It has a little LED lit on-off symbol thing here. And these are supposed to be like waterproof. That's why there's a O-ring gasket. I'm not going to use the gasket. It also comes with its connector, which I suppose is good in a way, but I'm not going to use it because, well, yeah. And there's no way I'm probably going to get those pins that I'm not going to be using out again. And the fact that these wires aren't long enough anyway. And also very stiff. But, so that's not what I was intending to do, but this is only an SPDT. I thought it was a DPDT. But that's alright. Just got to figure out where the LED is. I'm assuming it's these two outer pins because that says normally closed at the top there, that's normally open, and that would be its center. I can verify that. But anyway, greetings, the Astro30 here yet again, and welcome to part 2 of this build of this amplifier project. Now, in this video, what I'm going to be doing is I'm ordering a case to put everything in. I'm also going to fix the power amplifier issues that I've got with those resistors. And yeah, we're going to look at this switch as well. So what I need to do is I need to turn my multimeter on and I need to put it into continuity mode. And I need to figure out where the center of the switch is. I believe, because it's very hard to read, that's, yeah, C's down the bottom here. So if I put one lead there, that's the normally open. If I put the switch on and do it again, that goes away. There's the connection. So these should be the LED connections. And this switch is apparently rated at 6 amps, which is, well, interesting. Now, I don't know if this has a internal dropping resistor, current limiting resistor, but the pins here are just marked 1 and 2, which is not very descriptive. So if I measure across here, I got 2.8 volt DC drop that way, and 2.8 volt drop that way, so there must be a resistor there. If I use the supplied connector, which I don't know if this is indexed, well, it doesn't fit that way. Yeah, it must fit that way. No, it doesn't fit that way either. It fits that way. That doesn't seem to work because the pins are down here, not up there. So Maybe I am plugging it the wrong way around. So here we've got a black wire and a red wire. So that would be for the LED, I reckon. So I'm not going to apply a voltage directly to the pins here, but I will put it through a resistor. Okay, so I've got a 2K2 resistor here. I couldn't find a 10K offhand, but 2K2 should be fine. I've got my power supply set to 12.6 volt. In fact, I might just drop him down a bit further to just under 12, 11.5, 11.3, that's good enough. And I just conveniently have my connection wires to the power supply sitting here on the desk. So that one goes there, and that one goes there, and we turn the light on. It lights up. Isn't that special? Now I'm going to connect this to that little multi-vibrator circuit that I've got for the power supply, and that's got a 10K resistor on it, so I'm not sure if that's going to be too dull or not, but it should be alright. Okay, so I've got everything set up. I've got the multi-vibrator power supply that's connected together, just got the LED of the switch bodged into this JS2 connector, sitting up on top of the solder, and I might actually just turn the desk light off just so we can get a better look at that switch, and I'll plug it in and see what happens. Now, I don't think that's too dull. It does look pretty dull, but the camera's not going to do it any justice. No, I think that'll work just fine at that brightness. It doesn't want to be all that bright anyway. So moving on to the modification of the power amplifier modules, I do have a couple of 33 ohm 1 watt resistors to replace the resistors that are burning up in here. I do have another packet as well for this module. I don't have the replacement resistors with 110 ohms yet. They're on order from China. Now, I ended up with 2 watt 120 ohm resistors. The original resistance is 110. Now, the difference between 110 and 120 is only 10 ohms, and I've gone up to 120 rather than taking it down to 100. It is actually a better idea to go higher in resistance slightly than it is to go lower, because you've got to look at the current that is going to be limited through that resistor, and that value was obviously chosen originally to limit the current going into the emitters of the drivers up here to a certain milliamp range. So I don't think using 120 versus 110 is going to make that much of a difference to the operation of the amplifier. However, I'm still waiting for the bastards. So for now, I'm going to extract the 233 ohms, and then I'm going to figure out how I'm going to retrofit these so it doesn't look completely wanky. So I've moved to a place with a bit more natural light. Look how brown those have gone. They wouldn't have been very much longer for this world. They're stuffed. Alright, so now to clean up the holes and see how I'm going to fit them. Now I think that is a viable solution standing up. They're a bit proud of the board, but that's alright. I just wanted to keep the body of this resistor as far away from this potentiometer as possible. I could have laid them horizontal with the board, but I think that is a viable solution. I haven't soldered them in yet, but I'm going to do that now. Alright, they're soldered in now, and they do actually fit the 0.8mm hole that's drilled for the original resistors. But all the other resistors, according to the parts list of the original module, are all quarter watt apart from the 33 ohms, which are 1 watt devices, and the 220 ohm resistors that were put in parallel were also 1 watt devices. The rest are all half watt, well apart from the 10 ohm resistor there, which for the Zobel network. So now I can test it. Alright, I got the amplifier all hooked up to everything, like the dummy load and oscilloscope, etc. And I'm going to plug it in and see if we get an output signal. Now it's either going to work or it's going to blow up. Either way, we'll see what happens. So I'll plug him in, undim bulb. We do have an output signal. And we're getting 60 volt peak to peak out, which is good. Yeah, they're getting hot. If we look at the scope screen, notice how we've got a bit of a ring here. Not sure what's causing that. I reckon that ringing is going to be intermodulation distortion, or IMD. Although a lot of people say that that phenomenon doesn't exist. But so far, it's working fine. Those are just getting warm. So if it's not run at full power for long periods of time, where we start to get that oscillation, things will start to be cooled. But we are starting to get some heat into the heatsink, which is, yeah, okay. So I reckon those 1 watts will work, and these are going to be getting hot. I can feel the heat near the capacitor, so yeah, those resistors do need to be changed. It may also need a coil on the output. But even at 51 volt peak to peak, those resistors are just warm to the touch, well, hot to the touch, but they're not smoking hot, if you know what I mean. But I can smell the heat coming off these 110 ohm resistors though, and I can also feel it. It's quite warm around this area. Here it's not so bad. Alright, I guess the thing to do now is to do the other module and test that one and see, you know, if we get the same results. Okay, with a bit of faffing around, the second module is done, and now I'm ready to test it. Now I haven't actually touched the input sensitivity, so that is what's coming off the oscillator. Indeed, we have an output. Yeah, this one's ringing too. We can see that it's ringing. It may require an output inductor. The amplifier amplifies the sound, whilst the preamplifier amplifies the pre. Anyway, I'm going to disconnect that at the moment. I don't want to turn this into the let's modify the amplifier video, but what I do really want to do now is I'm possibly going to want to come up with an output inductor, which is just like an inductor across in parallel with a resistor, like a 10 ohm resistor, just to limit the possibility of the ringing on the output. That's usually due to because of, you know, long lead runs and trying to drive a capacitive load and all that sort of fun stuff. So I managed to find some enamel copper wire on an old power supply board. I ripped it apart and I've made up an air core of about 4.5 millimeters diameter. This is roughly about 15 millimeters long, and there's 15 turns there, and the diameter of the wire is 0.5 of a millimeter. I've got that soldered across a 22 ohm, not sure what wattage of resistor that is. A 10 ohm will do just fine. And what the inductance of that inductor is going to be roughly about 0.5 microhenries, around there. An inductance meter would be helpful, but I don't have access to one right now. So if we look at the scope screen, and the amplifier is turned on, but if I turn the signal up to clipping, and then change the time base. Notice how the ringing has gone? Isn't that interesting? So yes, I was right. The ringing that was present on the output signal is because of the leads and the load, and probably some form of a little bit of capacitance on the output. So an inductor in series with the output across a resistor, like most power amplifiers have, would benefit. So the final design, I'm going to actually have this going into a headphone board, which you plug your headphones in and it disconnects the speakers, etc. I'll put this inductor and resistor combination on that board, and I'll also put a PTC to prevent any short circuits, etc. Anyway, we're going to move on to the next bit now. That's some awesome head right there. Billions and billions of bubbles. Eratosthenes. And just like magic, the 2-watt resistors that I ordered have turned up about 2 weeks later. So let's have a quick look at these before I solder them in. That's basically all we got. 2 weeks wait for that. 120 ohm, 2-watt, 1% metal film resistors. Now they look pretty large because they're about 15 millimeters in length here. But if they were standing up on the board, like the other 33 ohms are, there should be just enough clearance there and enough lead length to bend them over at right angles. Even if they sit at a slight angle, it doesn't really matter. And that should fix the entire issue that the power amplifier is currently experiencing. So yeah, I'll get to doing that, and yeah, we'll come back. I think that'll work. Yeah. It clears most components. I mean, that one is touching the 10 ohm Zobel resistor, but yeah, that's probably the best I can get it to fit in there without these two resistors interfering with each other, that is. So I might solder them in like that and see how we go from there. Okay, yeah. Looks a bit like Frankenstein's penis, but it's functional. So I'm so glad of the way I laid this PCB out that it just makes it so much easier to make the modification without it making it look completely stupid. But well, it is kind of stupid looking, but yeah, it is what it is. But this should now stop the power amplifiers from self-destructing when, you know, running at full power. So now that I've got them soldered in, let's test the modules and see, you know, if they still even work. There might still be that slight oscillation on the output. I've still got the coil knocking about somewhere. And yeah, we'll just do some tests and make sure that it's functioning. And when it's at full power, it's not going to like self-destruct. Oh, and here's the original 110 ohm resistors I've just pulled off. The two at the top were the ones which were abused at full power. As we can see, they're fairly discoloured. And the other two are off the other module which wasn't quite abused at full power. We can certainly see a difference in colour. So those top two resistors weren't long for this world. Anyway, on to testing. Alrighty, I'm ready to test it now. Got it hooked up to the dummy load, oscilloscope and power supply, etc. So hopefully nothing goes up with a bang. Plug it in. We have a signal, which is always good. Turn up that. Got yeah, about 19.8 RMS coming out. Good. Yeah, they are getting hot. And I also noticed that, apart from it clipping a bit, that nasty ringing has also gone, which is interesting. Okay, I've turned it down to about half power now, and you could actually smell carbon starting to get really hot. So Yeah, I should have really redesigned the output stage, but that doesn't keep it to the classic original circuit. However, running at half power, yeah, they're getting hot. The 33 ohms not so much, but the 2-watt devices are getting hot. But the likelihood of the amplifiers being run at full power is pretty slim. So I'm just going to quickly test the other module off camera, and then we'll move on to something else. There's somebody at the door. There's somebody at the door. Thank you. Oh, Jesus Christ. The rack case is turned up, so let's get it inside and have a look. Well, come on. And there it is there, sitting on this desk today, because the other one's kind of in use. And I've actually got the components mocked up there on the other desk with tape, which the inside of the tape is the inside perimeter of the case, which is 430 long by 330 deep. It just gives me a good idea of where things were going to be put inside the case, and everything should fit fine. So anyway, I'm going to open this rather large box, which is a lot larger than the actual case is, but yeah, I always like opening packages, especially from Ultronics, because it's just so exciting. And by the way, this case cost me $145 plus the shipping, which was $13, I believe, and that was Road Express. I really should have paid an extra $11 and just made it $24 and had it Air Express. It would have got here a lot quicker. I've been waiting for it for over a week. But yeah, we'll open this outer cardboard box and find a bunch of packing peanuts. And yeah, their flyer for this month. Case, which is box take out. And I did actually ask them to send me one of their printed catalogues, so that'll be interesting to look at later. And there's the rack case itself. It's a 2-unit one, which is the H5038 model. So yeah, let's open the box. And I also got these equipment feet from J-Car. There's no catalogue number that was visible easily, so I've written it there, HP0832. Yeah, these are about $11, $12, something like that. And they're the 50mm diameter ones, so they're pretty large. But I reckon they'll look great on this. Right, so I have to open the box. Just to cut that tape there. That's about all I have to do. And I will turn it the correct way up to get the components out. And we have it there. We have one front panel, U-shaped style with captive nuts. Beauty. I believe this one is the rear panel itself, because you get a sub panel which is slightly smaller, which goes on the inside of the case. So I've got the sub panel as well. I need that for the front. And I believe they only give you one sub panel, not two. There's a little instruction booklet of how to put it together. 4 mounting rails for, well, one's for the sub panel, and then you get another 2 to mount, you know, transformers and other stuff inside the case. In this case I'm going to use 2 for the heatsink. Once I figure out what the distance between these holes are, there's the 2 sides and a loose screw. So that's the 2 sides. and I don't know why there's a loose screw, so those screws look like they're for the handle, but there's like 6 of them. Okay, whatever. That came out of this bag of screws, so it could be just a loose screw. I can't open the bag. There we go. So I'll put that in there. I'm not going to make this video too much longer because that's what the sides should have been in. Because there's no real necessity to film all of this. 2 handles are in this little package, but these will go on last. I'm not going to put them on now. And then that gives us the top panel, which is ventilated, which I might actually put back in the box in a minute. And then what I do need is, well, actually there's 2 ventilated panels. There should be only 1. I didn't realise both were ventilated. That's kind of annoying. That makes kind of mounting things a little bit more difficult. Well, I don't think it's going to be a terribly big issue. It just means I've got to change how I had it laid out, because I wasn't expecting ventilation holes on the bottom cover. The ones I used to get before didn't. So for some reason this one does, unless they've substituted the wrong panel. It is possible. I will have to have a look at the other rack case, but everything will fit in here. There's just enough room up here to put my headphone adapter board, which will be mounted to the sub panel. And yeah, so what I'm going to do is I'm going to put the sides on, the rear, the sub panel, but not the front. I just want to see how this case is going to look, but that's also going to make it now awkward for me to mount these feet properly. So yeah, that's not going to work, unfortunately, unless they were put like on the inside. But yeah, that looks kind of weird. Okay, it looks like these 6 larger screws, which I was confused about before, are for the sub panel mounting, and they're obviously going to be used on the other side of the case as well. I think that's right, because they've got threaded portions through here, so yeah, that's what we have. Anyway, I checked the other rack case that I've got lying around, and it does have ventilation holes on the bottom of it as well, so I didn't realise that. That's my own fault. But yeah, so let me get to continuing to assemble this thing, and we'll check back once I've actually got the sides and the bottom screwed together. So I think something along the lines of that is going to work. Means I'm going to have to change my idea of how the front panel was going to be laid out, because I don't know, because I don't think these wires are going to be long enough to reach the multi-vibrator, and I don't think there's enough room for the switch and the headphone socket going in a vertical direction. It comes awfully close to those rails, although it might work, except the switch would be there and the headphone socket would be there. It might look a little bit weird, but I've got to keep in mind the clearance that I'm going to need between these 2 rails, top and bottom. It would have been nice if they were slightly higher, but no, that's what the case is going to look like. The transformer is going to hang over the back of the rear vented slots, which is kind of okay and annoying, and that's the only way I can mount the power supply, because this needs to connect to there, and this wire is long enough to connect to there. So, and I'd put a star earth point probably here next to the transformer. That's basically how it's going to be laid out, and we'll push the heatsink all the way over. The front panel is the least of my worries right now. I'll figure that out when I've actually had the headphone board made, and I've got like a preamp in there and the switching circuitry and everything, so I can then work out how much front panel room I've got, so if I can lay them, you know, in a single row, straight line across the front panel, that's fine. The preamp's only going to be about that big, which leaves me space here, here, and here, so it should work out. And I've left enough room back here, as far as I know, although I'm going to have to now work with that constraint, for the input switching circuitry. So when I come to design that board, I'll make sure that it's, you know, going to fit within this gap here that I've got, and that's the total constraints that I've got. Because if I put these rails on the other set of holes on the other side here, well then this hangs over a ventilation slot, so you can't screw it down. However, it is looking like it's working out okay. And between the power amp and the back panel, I've got a good 60mm there, so that's, if I make the input board's width no more than 55, it'll fit in there just nicely. So anyway, that's what I've got to work with. So I might actually leave this video here for now because it's gone on long enough and you're all probably bored about this point. So in the next video I'm going to start marking out and drilling the holes for the transformer, star earth, the two PCBs. Not sure what to do with this multi-vibrator flasher unit thing, because I was intending to mount it on the back of the front panel here, but I forgot the headphone board in there as well. It's not going to mount that way. It's not going to work out too well. However, I could probably get away with mounting it next to the power supply down in there. I mean, that could work too. Yeah, well, it's worth a shot, or something like that. Anyway, I've got plenty of room to move this board over a bit, so yeah, I'll work that out in the next video of how I'm going to mount everything. It just means now I've got to change the plug that I've already soldered onto my LED. But that's perfectly fine. I can just make a new one. So yeah, if you enjoyed this video, please remember to go down below, rate, comment and subscribe if you haven't done so already. And this is the AEL480 saying see you in the next video. And it's a shame I can't use these, but oh well, it is what it is. Anyway, thanks for watching.